Good morning, Excel Geo. Today we're going to utilize the trapezoid rule to help us estimate the area under a curve. So let's take a look. Let's take a look at the function y equals negative x squared plus 2x plus 10 on the graph. We are going to create an area by enclosing the graph of this function, the x-axis, and the lines x equals 1 and x equals 4. How can we compute the area of this region? Do we have a formula? Well, our whole goal today is going to be deriving a formula. So the first thing I'm going to do is let's just go over some things I want you to know. The first thing I want you to know is x equals 1 and 4. If I take a look at that, this is x equals a, our starting point, and this is x equals b. Okay, in the formula. And we're also going to give you a value n. N is going to equal the number of trapezoids that we're going to break everything into. So number of trapezoids. And I'm going to tell you it is 3. So n in this case is going to equal 3 in it. All right, guys, so I want n for this problem to be 3. So we're going to break this shaded region into 3 trapezoids. The key thing is when we break into 3 trapezoids, we want to break into 3 trapezoids with the same exact height. So in order to find the length of the height that we want, we're going to take, your height will be b minus a over n. So in this case, b is 4 minus a is 1 over n, which is 3. So 4 minus 1 is 3. 3 over 3 is 1. The height of each trapezoid will be 1. What does that mean? Well, it means when I take a look at my graph here, I'm going to break it into trapezoids. We're going to break them into what I'm going to call a kind of a vertical trapezoid, where the height is actually going to be along the x-axis. So when they're saying that we're going to shade in this region, they're saying they want the region between x equals 1, x equals 4, and the x-axis. So this yellow region is the region in which they're talking about. And I want my height to lie along the x-axis, but I want each trapezoid to have a height of 1. So that means if I want each trapezoid to have a height of 1, I'm going to go from my starting point A, and I'm going to make marks 1 unit away up to B. Now, if we take a look at that, I made it 1 unit away up to the B. That means that the length of all my heights down here, if I label this, if I want these are my heights, all my heights will be consistent of my trapezoid. Because when I draw this trapezoid, I'm going to draw a vertical line down. All right, guys, there we go. A vertical line down. We're good? So we're going to form 3 trapezoids. 1, 2, that was a bad line. Sorry, guys. 1, 2, 3. So I'm going to connect these points that I had up there. All right, so the points were on the function for the trapezoid to have 1, 2, 3 trapezoids. Now, if you look at this graph, you're going to see that there's going to be some area under the curve that is not inside the area of the trapezoids. That is okay. We are using the trapezoidal rule as an estimation method. So we're estimating the area under the curve. So if we can find the area of each trapezoid, then we will be able to estimate the area under the curve. So let's talk about our trapezoid formula. Your trapezoid formula is 1/2 height times base 1 plus base 2. Now remember, when I talk about bases are the 2 parallel sides. And your height, we already know down here, we found our height to be 1. So you are going to, let's take a look. Let's make a table. Find the area of every trapezoid. So you have area of trapezoid 1, area of trapezoid 2, and area of trapezoid 3. And we're going to add them up to find that total area. Well, if I look at area of trapezoid 1, I have 1/2 times the height of 1. What's my base 1 and base 2? Well, they are the 2 vertical sides. So when I look at that, base 1 would be this segment and base 2 would be this segment. How do I find the length of it? Well, the length of that segment, since it's a vertical segment, would be the distance between the y value of 0 and your y value up top. So we need to know these points. Now this is 1. If I take a look at my points, this point up here will be 111. This point, the next point would be 210. The next point would be 3, 7. And then the last point would be 4, 2. All right, guys, so we have these points. Now, the length of this segment, so the length of my segment here, B1, would be 11. The length of B2 would be 10. The y value of those points on those functions will be your bases of your trapezoids. So in this one, I know I have, if I take a look at this, base 1 is 11 plus base 2 is 10. So I know the area of that first trapezoid would be 1/2 of 21, which is 10.5. Now let's look at my next trapezoid. If I look at my next trapezoid, I have base 1 from 2, base 2 for 2. So when I look at that and I put that function in, I have 1/2, the height is still 1. Base 1 would be that first purple highlighted would be 10. Base 2 would be 7. So I would have 10 plus 7. Well, that's half of 17. That would be 8.5. Now let's look at our last one. I don't want to do that because we already have, I'll do green. Base 1 and base 2. Again, the y values. It would be 7 and 2. So I look at this. I have 1/2. My height is 1. My y values of the 2 points on my function for those where the vertical line hits that function would be 7 plus 2. So that would be half of 9, which is 4.5. Now add them up, guys. 10.5 plus 8.5 plus 4.5, and you should have 23.5. Okay, so that's 23.5 units squared. And that's going to be an estimation. Now, is this area slightly larger than 23.5? That is fine. But this is a way that we can estimate the area under the curve. All right, so that would be my estimation. So what we're going to do, we are going to use a trapezoid in an attempt to closely represent the area under the curve. But what is the formula? Well, let's think about this. What is our formula? And I do think the tables definitely help with this, okay? So if we look at our formula, we already said n equals, make sure we know this is important, n equals the number of trapezoids. All right. And I know that the height is equivalent to b minus a over n. So if I was to add up trapezoids, all right? Now, if we take a look at this, your bases, okay? So if we make a chart, okay, how would this look? If I was to make a chart to find areas, and depending on how many trapezoids, I'd have area 1, area 2, area 3, and it's really going to go down to area n, whatever area n is, okay? Now, how am I going to use that to help me out? Well, let's think about this. Area 1 will always be, the height we already know. The area will be 1/2 b minus a over n, right? Times the function value at a. Function value at a means the y value at a. If you were talking about any function, f of a represents the y value when x is a. So when I say f of a, if I go back to my original function, I'm referring to the y value. I'm going to do it in yellow up here, that 11. That's f of a. The last value down here, if b is 4, the y value would be f of b. The function's value at a, the function's value at b. All right, guys? So if you take a look at this, this would be the function value at a plus, wait a minute, the next function value. Where does that next function value land? Well, that next function value lands at 10, right? It's that next function value was 10, but how do I figure it out if I'm trying to think about it abstractly, meaning it's a variable, and how did I get from 1 to 2? Well, I got from 1 to 2 because 1 was the height. 1 plus 1 gave me 2. So that means to get my next function value, it would be the function value of a plus h. That would be my first formula. Now in area 2, I would start at that you start where you landed, f of a plus h, and now I'm going to add another h. I'm adding another height, so then you're going to have plus the function's value at a plus 2h. For my third one, it's the same concept, guys. You're going to have f of a plus h, 2h, and I'm going to add another h, f of a plus 3h. Okay. And then for a to n, it's going to be 1/2. It's the last one. It's going to be 1/2 b minus a over n times the function value. It's going to actually, I'm just going to make it easier. It's going to be the value of b minus h plus the function's value at b. All right. So you're adding this all up. All right. And when we add it up, we are going to get our trapezoidal formula. Now, I can write this out in one long formula if I wanted to. What you're going to notice here is that we have a common thing. The 1/2 and the height is common in every single one of my functions. So I can actually just stick that out in front and add everything. The other thing I want you to notice is that f of a appears once and f of b appears once. But you're going to notice that the f of a plus h will be twice, and the a plus 2h is going to be twice. That pattern is going to continue. Everything in the middle will appear twice. It will be the base of two trapezoids. The two end vertical segments would only be the base of one trapezoid. But you'll notice up here, every middle trapezoid, every middle vertical segment is the base of two trapezoids. So if I look at this, I'm going to use I'll use the red, guys. This here is the base of two trapezoids. This here is the base of two trapezoids. Everything in the middle occurs twice. So when I can actually write this formula, because I would just add all this stuff together to get it, my trapezoidal rule states that if I want to use the trapezoid rule, I do 1/2 times the height, which is b minus a over n, which we said. And then I can just add all my function values, but you have to be careful. F of a appears once, and then it's like 2 times a plus h, plus 2 times a plus 2 heights, plus 2 times a plus 3 heights, and it's going to go all the way to f of b, which is that ending point. All right, guys? So let's take a look at another problem. Okay. Now, our next problem, I'm not giving you the graph. We're going to graph it, and it doesn't have to be perfect, and I'm going to show you how to do it. But do me a favor, guys. I don't want it to be 8 trapezoids. I want you to change that to just 4. We're going to just do 4 trapezoids, okay? Change that to 4 trapezoids. Find the area enclosed by the function y equals x cubed minus 9x squared plus 24x minus 10. And the x-axis between the lines 1 and 5. Use 4 trapezoids of equal width. All right, guys, 4 trapezoids of equal width. I didn't want to do 8. It seems like a lot. All right, guys, so key thing here is we're going to graph it first. Now, when you graph it, I want you to utilize your graphing calculator. So put it in your graphing calculator and just take a look at the graph. But I don't want you to just guess where points are. So I would like you to go to second graph and get to the table so you can actually plot some points. If I get to the table, okay, 0 is at -10, which is not on my graph. But I noticed that if I look at this graph, it says 1 is at 6. So I'm going to graph some points. Okay, 1 is at 6. 2 is at 10. 3 is at 8. Okay. I'm trying to estimate as best as I can, guys. 3, 8. And then I have 4 is at 6. And I have 5 is at 10. This one's going to be a little more challenging. So it's going to come up, go down, and up. Now, so this is a slightly different. This is a cubic graph because we have x cubed. But we're still going to do the same thing. Let's take a look at what we're going to break everything into. So we're breaking it into 4 trapezoids. That means 4 is n. So I know n is equivalent to 4. Okay, I can easily find my height. Height is b minus a, which is 5 minus 1 over 4, which is again 1. So that means that I am going to drop a vertical line starting. So like if I look at this, well, let's do this. If I have x is 1 and x is 5, let's do that, the outer side. So if I have x is 1, that means I have that's the starting, and that's the finishing at 5. So this here in red is my shaded region. Okay, that's my shaded region. Now we're going to estimate the area using the trapezoidal rule. We're going to break it into 4 trapezoids. So now we know the height is 1. Now you have to find the values of these points. So we already know them from the table, guys. So just write them down from the graphing calculator. I have 1, 6, 2, 10, 3, 8, right? 4, 6, and 5, 10. So write them just as they were on the table in the graphing calculator. I don't expect you to do them yourself. Now, if you'll notice now, this is also something interesting. Like you're going to have these trapezoids, but you'll see when you construct these trapezoids, like they're going to be they're slightly different, but they're still going to help us calculate the area under the curve. And I'm looking at my trapezoids. I'm going to drop those segments, those vertical segments, so that I have a height of 1. And I knew where to drop those vertical segments because I went 1 unit away from the starting point. So 1 plus 1 is 2, 2 plus 1 is 3, and so on. 3 plus 1 is 4, 4 plus 1 is 5. Now let's construct a table for the area. All right, guys, let's construct a table for the areas. So if you wanted to do that table for the areas, you can say, I have how many trapezoids in this case? I have 1, 2, 3, 4. So I'm looking at 4 areas. So if I take a look at my table, I'm looking at area 1, area 2, area 3, and area 4. And again, you're just doing, let's do our functions. So if I take a look at that, area 1 is 1/2, the height is 1 for all of them. Base 1 plus base 2, again, look at your y values. So it's going to be 6 plus 10. It would be your first 2 y values on that graph, 6 and 10. So that's it's going to be half of 16, which is 8. Now do your next one, 1/2 times 1. What are my values? It's going to be 10 and 8 are my next 2 values. So you have 10 and 8. It's half of 18, which is 9. Look at my next one. I have 1/2. My height is 1. All right. And look at I have 8. 8 is the base of that. My third one, 8 and 6. So 8 plus 6 is 14. Half of 14 is 7. Now let's look at the next one. 1/2 times 1, right? And then I have 6 plus 10. Half of 16 is 8. Now add them together, guys. What is going to be? So I have 8 plus 9 plus 7 plus 8. And you're going to have 32 units squared. And guys, I do believe it's easier to do it with a table. All right, I do. And that would be the estimation for the area under my curve. I do not expect you to graph these by hand. I expect you to use your graphing calculator to graph them. And when you hit second graph, that table feature to find your values for your X and Y points. All right, remember to find the width, the distance between the vertical segments. To find that distance between the vertical segments, that's your height. I don't know why it's not letting me. I'm trying to highlight, guys. It's not letting me. If I want to find that distance between that height right here, that is how I got it up here. My height. I make a vertical line 1 unit away from the starting point until I get to the ending point. That's how I get that height. All right. Now, if you have any questions, I know this is a little different concept that we've been working on than what we previously have been working on. Please come to office hours and I'll be more than happy to help you. You have 2 practice problems tonight. All right. You have practice 1 and 2. All right. But I'm going to change that. Make that for I think I'm going to change that bottom one too. So let's take a look at that bottom one and let's make N6. Make N6 on that bottom one for me. All right, guys, I don't want you to do 12. Make N6. All right. So that's the one thing I'm going to change. So you have 2 practice problems. On the bottom one, I would like you to make N6. All right. If you have any questions, please come to office hours. All right. I'll talk to you guys soon.